Hey guys, I just wanted to talk briefly about pathological science. The concept of pathological science has been applied to various scientific research programs. It's not a concept that has been that influential in philosophy of science, as far as I can tell. But there are various scientists who have accused certain research programs of being pathological. I just wanted to explore this a little bit. What exactly is pathological science? Well, I think, as is often the case, it's best to approach this through some specific examples. So one of the classic cases of pathological science is the case of the Canals of Mars. Back in the late 1800s, various astronomers thought that they saw networks of straight lines on the surface of Mars. Giovanni Schiaparelli was the first to identify these. He called them canali, which translated to canals. Schiaparelli did not intend that term to mean literal artificial canals. I think he was agnostic, at least initially, about what exactly they were. But there were many astronomers who did indeed propose more or less fanciful theories of what these might be. Some viewed the canals as evidence of alien civilization on Mars. Percival Lowell proposed that they were an advanced irrigation system. Lowell claimed to have observed the canals change appearance. So in particular, he claimed that as the Martian polar caps melted, the canals would grow thicker and darker, starting at the poles and then growing out like that towards the equator, which he took to support the irrigation hypothesis, that, well, the poles contain the water. As the water spreads over the planet, vegetation grows, making the canals appear larger and darker. There were more or less fanciful ideas about what these canals might be. More sceptical astronomers would try to explain them by appealing to geological processes like cracks in the Martian crust, stuff like that. Now, the debate on this continued until the 1910s, when it turned out that there actually just are no canals. It's not just that there's no alien civilization on Mars, it's that there are not even any canals there. There is nothing on the Martian surface that actually corresponds to the maps that were being drawn of these canals. The features that people thought they were seeing just weren't there. The problem was that telescopic images of Mars were very poor, so they were very much open to interpretation. They provided very ambiguous information. We're talking about observations at the very limits of detectability, people were just seeing things that weren't really there. So that's one supposed example of pathological science. Another classic example is the Nray controversy. This was back in the early 1900s, a French physicist called René Blondlot, whose name I'm almost certainly pronouncing incorrectly, but have to live with it. He thought that he had discovered a new form of radiation. Now, of course, at the time there were new forms of radiation being discovered seemingly all the time, right? We had X-rays, alpha, beta, gamma rays, cathode rays, black light, So there's this proliferation of forms of radiation. And Blondlot believed he had detected another form known as Nrays. He fired X-rays through a quartz prism. And quartz was known not to reflect X-ray radiation, but he had a detector off to the side, which would produce an electric spark. And it was something like the electric spark became brighter when the X-rays were directed at the prism. So Blondlot thought, well, there's radiation being reflected off the quartz, but it can't be the X-rays. So it must be a new type of radiation called Nrays. Basically, when Nrays are shot at an electric spark, they would purportedly change the brightness of the spark. And the changes were very faint. You have to be sat in a darkened room, let your eyes adapt. So again, you're talking about observations at the limits of detectability. But Blondlot then developed various other ways of detecting N-rays. So one other method was the calcium sulfide spot method, where you have circles of luminous paint and those appear brighter on being exposed to N-rays. Again, these observations are going to be at the sort of threshold of detectability. But many other scientists thought that they saw N-rays, and hundreds of papers were published. Various means of detecting and manipulating N-rays were developed. And so, the properties of N-rays were then discussed, and theories about them were proposed. But there were a lot of scientists who were skeptical on the grounds that they were unable to detect these things. The controversy was resolved when a scientist called Robert Wood went into Blondlot's laboratory. Blondlot was making observations of N-rays. He was performing a particular experiment on N-rays and was claiming to detect them. Wood asked him to repeat the experiment, but without telling Blondlot, he then removed parts of the equipment, and Blondlot reported exactly the same results. So pretty clearly, Blondlot wasn't actually seeing anything. Again, he reported the same results, both with the experimental setup as it was initially, and with it after it had been sabotaged. So it turns out there are no N-rays. He had nothing to measure. These two cases are classic cases of pathological science. It's the slogan is that pathological science is the science of things that aren't so. The question then is, well, what exactly is pathological science, right? Is this a useful conceptual category? I mean, certainly, I think we can agree that the case of the Canals of Mars and the case of Nrays were failures in some sense, right? I mean, these were not cases of good science. I think in those cases, scientists were not appropriately skeptical, or at least they weren't as skeptical as they should have been, and proper experimental procedures weren't followed, and so on. But is there some unique category of pathological science? Is it useful to understand these in terms of that category? So I think it's worth kind of contrasting pathological science with other cases of bad science or even non-science. So on the one hand, you have pseudoscience, right? Pathological science is distinct, or is supposed to be distinct, from pseudoscience. Pseudoscience, I take it, is going to be non-science that masquerades as science. It's going to be non-science that uses scientific jargon and is presented in such a way as if it was supported by appropriate scientific methods, or as if it had credibility from scientific institutions, but actually it doesn't. Like, pseudoscience occurs outside of normal scientific institutions and does not apply standard scientific practices. Obviously, it's it's difficult to give a precise definition, because there is a great deal of controversy to this day about the distinction between science and pseudoscience. But I think saying that pseudoscience is non-science that masquerades as science, that kind of captures the idea. Now, unlike pseudoscience, pathological science is genuine science. It's science, but it's bad science. Basically, that's the idea. So it contrasts with pseudoscience. Another obvious contrast is, although pathological science is wrong, we don't want to say that this is necessary and sufficient for pathological science, because many brilliant scientific ideas have turned out to be wrong. Newtonian mechanics is wrong, right? But it's not pathological. So incorrect science is not pathological science. Then there's fraudulent science. In the case of fraud, scientists deliberately falsify data for whatever reason. With pathological science, although the data may be faulty, there's no intent to deceive. It's not fraudulent. Honest scientists can find themselves caught up in pathological science, right? So there was no indication that Blondlot was lying or was trying to deceive anybody. There was no indication that the astronomers describing these canals were trying to deceive anybody. I mean, maybe they deceived themselves, but they weren't trying to, so it wasn't fraudulent. Then there are cases of external interference on science, like when the Soviet government forced biologists to endorse Lysenkoism. Again, in the case of pathological science, that's not going on, right? So I think with fraud and external interference, we can think of those as being cases where scientific institutions are sort of hijacked, as it were, either through deception or through force and coercion, So in the case of pathological science, by contrast, there's no dishonesty, there's no coercion, there's no fraud. Scientists are trying to follow proper scientific methods. Or maybe one way to put it is that pathological science occurs when science proceeds normally, whatever that means, in terms of its institutional operation. So you have pseudoscience, which is non-science with trappings of science. You have fraud and external interference, which involves intentional manipulation of scientific institutions for non-scientific ends. And then we have pathological science, which is none of these things, which is something else. So the concept of pathological science was initially proposed by a physicist called Irving Langmuir. Again, I'm not sure if I'm pronouncing that right. He proposed that it has 6 characteristics. So let me just state these characteristics. So number 1, the maximum effect that is observed is produced by a causative agent of barely detectable intensity, and the magnitude of the effect is substantially independent of the intensity of the cause. In the case of Nrays, for instance, one of the properties that they had is that certain substances could absorb them and then re-emit them later. But it turned out that if you would get like a brick to absorb Nrays and then re-emit it, this would be just at the threshold of detectability. If you then got 10 bricks, it would still be just at the threshold of detectability. So the effect is independent of the intensity of the cause, right? The effect always remains a threshold phenomenon. Of course, this is a little bit more difficult to apply to something like the case of the Canals of Mars, because again, like in that case, it was just a matter of the detection instruments were limited, poor telescope resolution and so on. But second, the effect is of a magnitude that remains close to the limit of detectability, or many measurements are necessary because of the very low statistical significance of the results. In these cases of pathological science, we're dealing with threshold effects, right? That's the point really of points 1 and 2, is that pathological science involves, theories or models or explanations which are built on observations of threshold effects. Number 3, pathological science involves claims of great accuracy. Number 4, it involves fantastic theories contrary to experience. Number 5, criticisms are met by ad hoc excuses thought up on the spur of the moment. Number 6, the ratio of supporters to critics rises up to somewhere near 50% and then falls gradually to oblivion. And of course, the problem with a lot of these cases is that you can find very similar things going on in perfectly standard science. So when you take, for instance, criticisms are met by ad hoc excuses thought up on the spur of the moment. I mean, I'm not really sure about the spur of the moment point, but certainly ad hoc hypotheses are standardly, that's a standard move to avoid the falsification of one's theories. When the orbit of Mercury seemed to contradict the predictions of Newtonian mechanics, you don't just give up Newtonian mechanics, you come up with ad hoc hypotheses to explain it. You say, well, maybe there's another planet there. And when you don't find the planet, you say, well, maybe it's a ring of asteroids or some other type of material, or whatever, right? There are all sorts of things that you can do, all sorts of hypotheses you can come up with to protect theories from apparent falsification. The other point is, so what seems central to pathological science is this point about threshold effects, right? We're dealing with things at the very limit of detectability. And that means that the data is very much open to interpretation. But again, that's the case in normal science as well. So just to take a classic example of this, in Eddington's eclipse photographs, which were used to confirm general relativity, or at least that was one of the primary pieces of evidence that confirmed general relativity. The effect is very, very small and very difficult to detect. So both Newtonian mechanics and general relativity predict that a large mass, such as the sun, will deflect light. General relativity predicts a greater degree of deflection, a greater degree of light bending. In fact, I think so Einstein's prediction is 1.7 seconds of arc. Newton's prediction would be about 0.8 seconds of arc. This is a tiny, the effect is very, very small, right? It's about, I believe, the width of a penny viewed from about a mile away is what I've heard for this particular observation. So scientists are working at the limits of detectability, and they're also going to be working, especially back when these observations were made over 100 years ago, they're also be working in quite difficult conditions, because the measurements obviously can only be made during a total solar eclipse. You have to compare the positions of the stars at night with the positions of the stars when they are right next to the sun, when they're just grazing the edge of the sun. And obviously you can only do that during a total solar eclipse. So there are not many opportunities to get this data. It did require people to go out to all various corners of the globe. Eddington's expedition went to Brazil and West Africa. So there was a team that went to Brazil, a team that went to West Africa, and they had 3 telescopes. The team in Brazil had 2 telescopes, the team in West Africa had 1 telescope. All of the photographs that were produced were quite poor quality, unsurprisingly. And, they're, again, very much open to interpretation. Some of them were just obscured by clouds. Now, from 2 of the telescopes, the photographs had seemed to confirm the Einstein's prediction, but from 1 of the telescopes, the results were very close to Newton's prediction. So it was, the data itself was quite open to interpretation. Now, I mean, this is not to say there was anything wrong with Eddington's behaviour as a scientist. It's just to say that what he actually got were a lot of photographs that many of which were just unusable completely. Even the ones that were usable were very poor. And actually, if you looked at the photographs from just 1 of the telescopes, then you might say, well, that actually confirms Newton's prediction, not Einstein's. So there he had to interpret the data, and this isn't unusual. This kind of massaging of the data is quite a standard practice, especially when we're dealing with observations that are made under difficult conditions, observations that involve these threshold effects. So so in that respect, it's not obvious that it's not obvious that there's anything necessarily wrong with the fact that scientists observing the canals of Mars were bringing their own interpretations to the data, or I should say scientists who thought they were observing the canals of Mars bringing their own interpretations to it. It's not really avoidable in those sort of situations. So I think there are a few problems with the very concept of pathological science, and I think there are good reasons why this concept hasn't really been adopted by philosophers of science or by sociologists or historians of science. First of all, it seems to me to be superfluous, right? So it's not clear to me why we really need a special concept of pathological science. It seems like we can account for what happened in many of these cases by just saying that actually there was just we can just be specific about the ways in which people failed to be good scientists. So in the case of Blondlot and the Nrays, for instance, well, he failed to properly control his experiments. He also had a tendency to refuse to cooperate with critics. He didn't provide very good detail of his experimental setup. So there are various ways in which Blondlot just wasn't actually a very great scientist, right? But then, you might say, okay, well, that's pathological science then. But on the other hand, if there's something, bad about scientific research, if it's sloppy in some way, surely it's better to just specify the specific way in which the research is sloppy, rather than try to box it all into this pathological science category. In general, it's important to be aware that even the best scientific research is often flawed in various ways. One of the dangers of sorting science into the pathological and non-pathological categories is that it obscures the way in which non-pathological science it obscures the limits of all experiments and all methodologies. It is surely better to just encourage general critical thinking about what goes on in science, rather than trying to box it all into one of two categories. Even within science as it normally proceeds, there are lots of there are lots of problems, right? The tendency to encourage scientists to publish or perish, plus the fact that negative results are often not published because they're not interesting. This can end up leading to situations where there's a kind of bias towards producing positive results, even when that may be kind of sloppy. So it's important to be aware of the ways in which even normal science can lead people astray, and this concept of pathological science might get in the way of thinking critically about that. The second point is it's not really clear to me that pathological science is actually a problem, right? So in the case of pseudoscience or fraud or external interference in science, we can understand why these are problematic. Pseudoscience will lead to negative outcomes, like when you get the anti-vaccine stuff or creationism being taught in schools. Same with fraud and external interference. With pathological science, because scientific institutions operate as they do normally, it will be uncovered relatively quickly. If you actually look at the cases that have been suggested as pathological science, it's along with the two I mentioned, cold fusion, polywater, the Allison effect. There's various different cases, but they all tend to be resolved relatively quickly. In fact, I think the longest one, the one that went on the longest, was the Canals of Mars, and that was just a few decades. Third, the necessary condition for something being pathological science is that it turns out to be false. If it had turned out that there really were Nrays, then Blondlot would have been hailed as making a really important discovery. He would have been hailed as, as a good scientist, despite the sloppiness of his work. So the judgment that something is pathological science is made retrospectively, only after the science has been settled. That's the only way we can reliably judge it, right? When we look back and we find these cases of people who were kind of sloppy in their research, right? They weren't applying proper experimental controls or whatever, or they were not being appropriately skeptical in their interpretation of the observations, and it turns out they were wrong, right? It turns out they weren't seeing what they thought they were seeing. So we say that's pathological science. But of course, if it had turned out that they were seeing what they thought they were seeing, if it had turned out that they were Nrays or Canals of Mars, nobody would be calling that pathological science. Again, compare that to pseudoscience, fraud, external interference. These all have features such that they can be identified as such at the time of occurrence. I mean, it may be difficult to specify exactly what those features are, as we all know, the distinction between science and pseudoscience is very difficult to draw. But whatever that distinction amounts to, we can identify, or we should be able to identify pseudoscience as it is occurring. And what counts as pseudoscience, 50 years ago, still counts as pseudoscience today. And this is so even if the pseudoscientific or fraudulent idea is later shown to be correct. Even if it had turned out that, say, Lysenkoism was true, right? Even if we did eventually gather evidence that it was true, the fact that the Soviet government was forcing biologists to endorse that idea is still a problem. Even if it turns out that some pseudoscience, I don't know, one of these quantum mystics or whatever, even if that kind of stuff turns out to be true, today it's still pseudoscience. So yeah, it seems that, again, maybe this just is another way of saying that the concept of pathological science is not really very, very useful. But certainly it seems problematic to me that this is something which really can only be judged retrospectively. And I mean, I guess this leads to the fourth point, which is that if we were to try to apply this concept to science as it is today, to science today, or if we were to try to apply it in the present, it seems to me there's a real danger that it would kind of stifle scientific research. It would lead to the rejection of potentially fruitful ideas. The vast majority of scientific ideas will die out, right? That's just how science is. Okay, it's red in tooth and claw. You constantly produce new ideas, and the vast majority of them will be cut down. But that generation of new ideas is an important part of the scientific process. And revolutionary science, right? When a new idea is proposed that does raise a genuine challenge to the current paradigms, it's often going to be based on relatively shaky foundations, at least initially. It's going to involve the use of new instruments. It's going to push the boundaries of detectability. The cases that are taken as pathological science, I mean, from another perspective, it just looks like science as usual, right? These are radical new ideas based on poorly understood observational technologies that turned out to be wrong. And that's the way science works, right? The vast majority of scientific ideas turn out to be wrong. If you were to apply mechanisms for weeding out pathological science or for preventing pathological science, that might also stifle scientific work. It might reduce the open-mindedness of science and make it more conservative. If we take the Popperian idea that science is supposed to proceed through bold conjectures that make risky novel predictions that are open to refutation by experiment, well, that's what happened, right? That's what was going on in these cases of pathological science. I mean, certainly the Canals of Mars, that's a bold conjecture, and it was open to empirical refutation. It easily was, because that's what happened, right? It was refuted in the end. All that needed to happen was improvement in the instrumental, in the means of imaging Mars. Again, Nrays, right? Bold conjecture, open to refutation, and it was refuted. So, this looks like science working as it should do. Of course, I suppose you could say, well, this is just a problem for that kind of view of science, right? Maybe this is just another problem with Popper's view of science, right? That it ends up judging pathological science to be good science. That's Well, that's pretty much it. That's pretty much all I wanted to talk about. So, yeah, there is this idea of pathological science. I'm not convinced that it's a particularly useful idea, and it does seem that most people who talk about science agree with that because it's not a concept that is applied very often, at least as far as I can tell. Most philosophers and historians and sociologists and so on don't seem to appeal to it. But I thought it was just worth talking about because, well, there are some people who do. So yeah, that's all. Bye bye.